Well, a little bit bummed today. Okay, so I was talking to Johnny a couple days ago. Talk about blockchains, and Johnny gave me a block. I tried to include it in my blockchain. Turns out it wasn't a valid block though. Johnny lied to me, and I'm annoyed. I'm so annoyed. I trusted Johnny. That was a mistake. Because we're dealing with blockchains. It's the old thing about trust but verify. Heck no. You can't trust Johnny. You got to verify everything that Johnny does now. It's ridiculous. No trust, all verify. That's what we're doing in blockchains. That's what we're doing today. All right, so we got some blocks. We've got to chain them together. We've got to make sure that each block that we chain together is valid. Okay, so it can't have junk data. It needs to be properly stateful. It needs to spend, boxes. It needs to spend UTXOs that actually exist and haven't been spent already. And we need to make sure that the transactions are actually authorized to be spent. So there's lots of verification, lots of little checks we have to do on each block that we consider in a blockchain. And so that's what we're engineering here today. Got our IntelliJ here. I think the last time that I did an engineering broadcast like this, we were working on the mempool. Got it all implemented and integrated, and so now we can have transactions in our system. We've got to make sure that those transactions are valid. Okay, so transaction is just something that spends the outputs of a previous transaction and creates new outputs that can be spent in future transactions. Those outputs are, of course, locked by propositions and whatnot. But that, that's part of authorization validation. We'll get to that in a little bit. But there is some basic validation that needs to be performed before a transaction can go into the mempool. That's called syntax validation. Okay, so syntax validation, it's a type of contextless validation. So it's a validation that doesn't require the context of any previous transactions or previous blocks to perform that validation, but it performs that validation on a transaction. Okay, so there's no state, there's no context, nothing like that. We can just look at the specific transaction and quickly tell you if certain things about it are invalid. So that's what we do here, transaction syntax validation. We're checking for, at least for now, we're checking for basically these 6 things. First thing, we need to verify that our transaction actually references, outputs of a previous transaction. Okay, so those are called the inputs. And, there needs to be at least one of them. There needs to be entropy that goes into your transaction. So it needs to spend something in order to create something. Next, we have distinct inputs validation. Okay, so you need to have at least one input, but if you have more than one, then they all need to be distinct. Okay, so you can't reference the same input of you can't reference a previous transaction's output more than once within your transaction. Actually, that's more than once ever. Of all transactions within all blocks on your blockchain. Okay, next up, maximum outputs count validation. So this is just verifying that the number of outputs on your transaction doesn't exceed, I think that it's 32,000. Yeah. You can't have more than 32,000 outputs on your transaction. And that's just because we reference transaction outputs by their index, but that index we represent as a short value just to save space. Realistically, why do you need more than 32,000 outputs? That's just kind of what we picked. Okay, next validation, positive timestamp. So each transaction has an associated timestamp, and that needs to be greater than or equal to 0. We talked about this for a bit. We went back and forth. Should we allow negative numbers, first of all? It's technically valid, but it's a little bit of a gray area. That means that your timestamp is referencing dates and times before January 1st of 1970. That may be a valid use case, but it may not be well supported in all languages or platforms, so we wanted to avoid the issue for now. But that still leaves January 1st of 1970, which is going to predate, blockchain technology. Any blockchain in existence right now didn't exist back then. So do we want to allow transactions to be formed that predate blockchains? We decided, well, yeah, maybe. That might be doable. There's no reason that a transaction, can't represent something, a transaction that existed before blockchain technology. Maybe it's a transaction that happened in, 1980. I bought coffee back then. Well, I didn't. I'm sure someone else did, though. So anyway, that's just, validating that. Okay, positive output values validation. So a transaction also produces new outputs. For example, it can output poly values or arbit values or asset values. And each of those types of things, they contain a quantity of some sort, and that quantity needs to be greater than 0. Okay, so you can't produce a negative quantity poly output. That would be ridiculous. Be fun though. I wonder if there are any blockchains that don't validate that. Start stealing funds from them. New bank robbery scheme. Let's do it. Okay, final syntax validation. We need to make sure that we have sufficient funds. And this is something that we could not previously do in Dion transactions because of the structure of Dion transactions. In Tetra, so our new major release, the transaction is structured a little bit different in that our inputs actually contain the value. It's like the value of the box that you're referencing. That does mean that you're duplicating data within your transactions. So you pay a penalty as far as number of bytes go, but it does allow for a lot more stateless validation of transactions. Okay, because you need to make sure that the boxes that you are spending, the accumulated sum total quantity of those boxes, well, you need to have enough of that quantity in order to create outputs of some quantity. Okay, so you can't go from $30 to $50, but you could go from $50 to $30. That's the opposite case. That one's okay. But you can't just make something from nothing. So that's what sufficient funds validation means. Okay, so that's just basic syntax validation of a transaction. It's stateless and it doesn't require the context of any previous transactions or blocks within the chain. But if we did want something that considered a little bit of context, then we move on to what's called semantic validation. Semantic validation validates the semantics of a transaction by verifying for each input, the claimed value or proposition matches the data defined in the referenced output. I guess I could probably say here. Okay, so this is making sure that the data that is on chain, so the box value and the proposition associated with the output, the proposition associated with the input should match the address associated with the output that is being spent. So we need to do just some data comparison there. And then next up, this is the more important one. For each input, the referenced output is still spendable. Okay, so this is what prevents the double spending attacks in blockchains. So we do so by tracking the state of unspent boxes, I guess is how you could say it. So those are the two main steps. We first do the data validation. So we compare the box value that's claimed in the transaction's input. We compare it against the box value stored on our chain on the transaction output that is being spent. Okay, so just making sure that they're not lying about the box value. And then next one, make sure that the spending address associated with the output on the transaction being spent contains the same evidence as the proposition on the input that is spending that output. Okay, so this is where you're revealing a verification key, for example. That gets revealed on the transaction, and that verification key needs to map to a proposition that maps to evidence that matches the address associated with the output. Okay, and then next one, spendable validation. This is hooking into a new mechanism called box state that just tracks the state of spendable boxes along a chain. And this is just hooking in to see if for each input, verifying that the box ID that it's spending still exists and is spendable. Okay, so that's transaction semantic validation. A block body contains several transactions. So we need to do both of these validation steps on all of the transactions within a block body. But we also need to run those verifications in the proper order that they are defined in the block body. And the transactions at the end of a block can reference transactions at the beginning of a block, for example. So we have like interblock dependencies that we need to be able to support. So first up is body syntax validation. So a block body needs to validate, well, a few things. Number one, it needs to validate that all of the transactions within that block spend distinct outputs of previous transactions. So you can't have any double spends within a block. So that's what we're validating right here. Next, we have validated transactions. So this is just calling in for each transaction within this block body. We need to call transaction syntax validation. So body syntax validation just wraps around transaction syntax validation. And we've got a couple steps here to do that. And then we also have body semantic validation. And as you could probably guess, body semantic validation wraps around transaction semantic validation. The difference, though, is that, as I mentioned, it needs to do the validation of each transaction within the body in order. So the validation of the second transaction within a block depends on the state after the first transaction of the block has been accounted for. So we need to augment our box state mechanism for each iteration as we traverse through our block body. We need to augment it with some additional boxes that have been spent or additional boxes that have been created. And so that's what we're doing in here. These two methods are doing that. Okay, so we've got our transaction syntax validation, transaction semantic validation, body syntax validation, and body semantic validation. Those things are all associated with the ledger, so like the application layer of your blockchain. They don't really touch the headers. Block headers we already have validation for. Those like one of the first things that we implemented in Tetra. And it just uses our first approach at validation. We came up with the separation of syntax from semantic validation a bit later. And there's a third one that I'm not mentioning in here that has not been implemented yet. It's called authorization validation. And that's just verifying that the proofs satisfy the propositions for the transactions. So that's going to happen soon. I haven't implemented it yet, but it's a third category of validation. So we'll have transaction authorization validation and body validation authorization. But we can follow that same pattern of having syntax, semantic, and authorization validation for block headers as well. We haven't done it yet, but we plan to in the future. So we'll split up this block header validation implementation into those three different categories of validation. The idea is just that some validation checks are more expensive than others. So do the cheap ones first so that you can eagerly fail on those and only do the expensive ones if you absolutely have to. Okay, so those are like our 3 categories of validation. So with that in mind, again, these are just like kind of independent units, independent components. They haven't been integrated yet. So that's what we're working on right now. To integrate these into our program, that's where we hop into. Well, okay, so I'm like halfway through this refactor. It used to be that all of this logic was embedded in this demo program. Yeah, we got some red text because I'm still working on it. But this demo program used to be, I don't know, like 400 lines long. It was really, really big. And it was exceeding the scope of what a program was meant to be. So I decided to move some things out. Among them was like how we handle a peer-to-peer connection. And that's kind of our main area where we need to validate block bodies especially. But we also need to validate transactions that get gossiped over the network. And on that note, there's also the RPC server, which I moved out, the interpreter for it, because that also needs to perform validation steps on transactions. Okay, so where the heck did I move all this stuff to? Blockchain peer handler used to be implemented over in the networking package, but because of our interpretation of this peer handler requiring so much from our application, I decided to move it into our demo package. And honestly, this is probably going to get moved even further. You know what? Maybe we're going to do that right now. What do you think? So let's hop over to build.sbt. We're going to make ourselves a new module. This is a big day. I did not plan on doing this right now, but we're going to do it. We're going to make a new module called blockchain. It's happening. We're making a blockchain module. It's going to depend on a whole bunch of other modules, but it exists here. Got to update a few things. Yeah, sure, we'll have it depend on all of these. Don't have a dependencies .blockchains. Let's go make one. Probably just going to depend on these things anyway. Plus maybe. No, it's probably just those. Cool. Okay, we got our module. Hopefully that resolves. Yep. Now we need to add this to our aggregate up here. And go. Oh, geez. SBT's got to do its thing. What kind of music do you want? Night driving. This looks like fun. Wowee. I don't know, maybe someday it'll finish. Look at that. Okay. Got ourselves a new blockchain module. So let's make ourselves a source, main, Scala, code, topple, blockchain. Ooh, I forgot to do a thing though. I need demo to depend on it. Let's just add that down here. It's on blockchain. Fresh. Refresh. Go. Thank you. Okay, but while it does that, we can go ahead and start moving some things. I'm not gonna let IntelliJ do this for me because it's not gonna go well. I'm gonna do it myself. I don't like this input at the end here for this particular one, but for now I'm gonna keep it. Okay. Paste everything below the package. There. Yep. Okay, we'll get rid of this one now. Surely it's gonna. Where's the error that I'm looking for? Not that one. Not that one. Not that one. Still not that one. What am I looking for? Not that one. This one. And I'll explain what this blockchain peer handler implementation thingy does in a second. I just wanted to move some of this stuff out. Okay, so that's one thing. Oh goodness, lots of things are. Okay. Gonna need logging. Just steal it from this guy down here. Okay, so I need that. And then I also basically need to depend on all of these things. Deduplicate them though. Okay, so I don't need that. Don't need that. I do need consensus. I do need minting. I do technically need scripting. Need common interpreters. I need networking. I need CATS ACA. I need topple gRPC. And I am blockchain, so I don't need that. Refresh. I believe in you. Come on, SPT. Thank you. Okay, hopefully this figures all the red stuff out. Yes? Come on. There we go. Come on, you can do it. Yes, there we go. No more red text. Perfect. Okay, we got that one. Move it over. We need local chain broadcaster. Cool. Do that, and then couple RPC server. All right. Last one that I'm going to make. Blockchain. I don't know exactly what I'm going to do in this one. This one's basically just going to be a program. How about that? It's going to return an F unit. It's going to take in a whole bunch of stuff, I'm sure. It's basically, I'll close everything else. It's basically just going to replace our demo program. So why don't I just do that? Blockchain. Okay, that's going to take a little bit to resolve, and I'm sure there's going to be lots of problems with it, but whatever. I'm just going to get rid of demo program now. All that leaves is Tetra demo and Tetra super demo. I'll have to refactor those as well, but let's get blockchain working. Well, okay, so before I even get to that, let me explain a couple of these things here. Blockchain peer handler implementation. This thing is an interpreter for blockchain peer handler, which I never got rid of those imports. I can go ahead and fix that though. Okay, so for each connected peer, there's a new peer-to-peer connection. Invoke this method to handle the peer. A client associated with a specific peer. Yeah, whatever. And doesn't really return much, so okay. So yeah, all this does is it uses that peer and does something essentially forever. So maybe I actually can. I'll just call this a forever running void. It just runs forever and it does something using that peer. Okay, and then we interpret it using this thing. I called it V2. That's not going to be the actual name. Don't worry. There was a different approach that we had before, but it was just like a super naive approach, and it immediately fetched all of the data from the peer and then validated it. This new approach, instead, it's a bit more, I don't know, pessimistic, you could say. Our goal with this interpreter here, though, so for each peer, we need to do essentially 3 things. We need to process block notifications. So anytime the remote peer adopts a block, we need to do something about that on our local node. Second thing, when a remote peer processes or adopts a transaction into their mempool, they notify us, and we need to do something about that notification. Then finally, we have just like a forever running background process that just checks the common ancestor between the remote peer and our local node, and then logs it out. We'll do more with that later, but it's just kind of proving that it works for now. Anyway, those are like the 3 main things that we need to do. This is also where we integrate the actual like validation logic, but I'll get to that later. I don't even know if I'll get to it today. We're like halfway through already. Okay, so anyway, that's one thing. Another change that I made here is this Topple RPC server. This used to just be embedded in our demo program file. It was basically doing interpretation logic inside of a program, which I didn't like. So I instead moved it into a separate interpreter. So Come on, IntelliJ, don't do this. Oh, geez. Okay. Interpreter which serves tuple RPC data using blockchain, using local blockchain interpreters. These are all the interpreters that are needed. I really don't feel like documenting all of them though. This should have a public return declaration. Wow. Okay, it's not going to help me. So yeah. So yeah, I just moved the interpreter for our tuple RPC stuff to a separate file. Then we serve essentially this interpreter to a user when they try to connect over gRPC. Okay, next one, local chain broadcaster. This is an interpreter for the local chain algebra, but it just wraps some other local chain interpreter. But it intercepts calls to this adopt method and inserts broadcasts or announces those in an ACA-Stream source. So what gets returned here is a new interpreter for the local chain, as well as a source of block IDs that have been adopted by this particular node. We can then use this particular source, well, for a couple different purposes. Number one, we could announce it over RPC. Number two, we could announce it over peer-to-peer connections as well to notify other peers of those adoptions. And then I want to do one more thing. It's basically the same thing as this concept here, but it's going to be a mempool broadcaster. Okay, so it's going to be an interpreter for the mempool, but it's going to do the same thing where anytime we add a transaction to the mempool, we're going to also announce it into an ACA-Stream source. Okay, so we're going to do a make as always. We need to take some sort of delegate mempool. And this is going to return an F of a tuple containing a new interpreter for our mempool and a source of typed identify. Let's actually, I'm not going to use materialized value. So I'm going to import these. Okay, and then just split this open. I'll copy paste, why not? I'm going to need a couple of these though. Hang on. Need async. We're dealing with materialized ACA-Stream that returns a future. Well, we also need to oh yeah, this is the main one. I guess we don't need async for that particular purpose. We just need it implicitly for another purpose. Anyway, it doesn't matter. Just bring it in. And we need an implicit materializer because we're dealing with ACA-Streams, so we'll bring that. And then now I'll copy paste. Don't need that. Don't need that. Probably don't need that. But I do need the source, so keep that. It needs more from our cat's ACA library. I'll just underscore that. That should get us our source.backpressure Q. Indeed. Okay, so now we can create a new mempool algebra. It doesn't, I can't find map, so we'll bring in implicits that underscore. Okay, now we don't need any of those. So mempool does different things. We'll put these. Okay, so the read call, I'm going to hook into our delegate. So read block ID, that returns a set. Good enough. Okay. I'll leave our add the same for now. Then remove is going to do, it's just going to hook into our delegate. We'll remove that transaction ID. Okay, so now this is the one that we actually need to change. So we're still going to hook into our delegate. So mempool.add transaction ID. In addition, we also want to offer it to our queue. Okay. And we're pretty much done. Okay. So now I want to hop back into blockchain because now we need to update a few things to make all this fun stuff work. Let's close that. Okay, so this is where I'm spinning up our interpreter, so local chain broadcaster, like yeah, using that broadcast interpreter. I'm gonna just duplicate this line. Pool, underscore that, and then local transaction adoption source. This is going to be mempool broadcaster. Make, then we pass in our delegate, mempool. That replaces that. We don't need that anymore. I wanted to get rid of it. Although we may still need it. Yeah, I think I don't need exactly that. So the source that gets emitted in, well, both of these cases, it's just a single use source. So I need something a little bit different because I need to be able to broadcast that source. So to do that, say broadcast hub.sync. And we'll actually, so it's, let's go over there for now. We need our local block adoptions source.toMat. Then we can lift to F. I'll put an underscore on that. Then all I've done is I've taken this single use source and I've turned it into a broadcast source. So this is the same type, but I can reuse it now. I'm going to do the same thing down here for the mempool. So okay. Cool. Now I can get rid of that. Okay, remote transactions sync. I don't think that I need this anymore. I don't think that I need that anymore either. Yeah, I'm just going to get rid of them. Because the logic, or the reason that I needed those before was just so that I could have a place to send things after putting things in a mempool so that they could be rebroadcast, or after adopting a block so they could be rebroadcast. But now that just gets implicitly handled anytime we adopt a new block or add a new transaction to the mempool. It just automatically goes into this source and we can read from it later on. Okay, so now in here, this is our make method before. I no longer need this broadcast block because it happens automatically in our local chain interpreter. I no longer need to broadcast a transaction because that happens automatically anytime it goes into the mempool. So I probably need to change a couple of these. Broadcast transaction can go away. Probably didn't even, I didn't handle that in there. So I don't need to worry about it there. Nor there. Nor there. Come on, it's somewhere in here. This one. Broadcast transaction. Got rid of that. And now I can get rid of this step. And that log message. Because it happens automatically. Okay, what else does this need though? Oh, nothing. Just took IntelliJ a second. Okay. Come on. Fix the imports. Cool. Nice. This needs a return type. Now I need to fix my call to this one to line up the arguments. So local chain, header validation, transaction syntax, transaction semantic, body syntax, body semantic, plot data store, header store, body store, transaction store, mempool, at local block ID at height. That happens there. Got a triple question mark for now. I can come back to that later though. Okay. So now I need to update these references. This is, what did I call it? Local block adoption source. Okay. I'll have a log message on this too. I already typed, but it's just kidding. I don't need to do that. Okay. Hopefully that's good. Tuple RPC server. Don't need to broadcast this anymore because it happens when it goes into the mempool. We need a return type. Okay. That's all good. Get rid of it now. Don't need to do this anymore. Can get rid of this. I think that right now we have, well, we don't actually care, so just ignore. Yeah. Okay. So our minted block stream, I'm basically just skipping all validation on it now. And I'm immediately adopting any block that we mint, because I'm assuming that it's valid. Oh my goodness. Just validated, not valid. Come on, work. Whatever. I'm sure it'll figure it out eventually. What am I missing here? I don't know why it's making me provide this F-type. Or, oh, okay, never mind. It's because of this. Does it need that in an F context, really? I guess so. Whatever, I'll be lazy for now. Okay. Hopefully it doesn't actually need this anymore. I can figure it out. Okay. Got a lot of extra imports that we don't need. Away. Okay, again, I'm sure it'll figure it out eventually. There we go. Okay. So now we can get rid of a couple of things that we don't need in here. I guess that was the one thing. Okay. Missing anything in any of these other files? That all looks okay. That all looks okay. Yep. Then this all looks good. Okay. So now we need to hook this up to our. Let's start with Tetra Super demo. Okay, so what does it need? Header store moves up, body store moves up, transaction store moves up. Slot data store, I'm gonna reorganize that. Put that in order. Okay, local chain moves up. ID tree goes away, block heights moves up. Add 25519 resource moves up. Wow. I feel like I need to reorganize these here as well a little bit. I'm gonna move these up. Yeah, I'll keep those there. That's probably fine, but I'm gonna need rename this peer-to-peer host and peer-to-peer port. Okay. Oh, back over here. Local chain, block heights, header validation. Okay, transaction syntax validation I do not have yet, so make a little bit of room for those. Okay, transaction syntax validation is oops. Oh, it's got it. Nice. Okay. Does it need anything? It does not. Okay, we got our transaction syntax validation. We need our transaction semantic validation. What does this one need, though? Come on. Analyzing? Okay, well, in the meantime, body syntax validation. And body semantic. Second. Yogi. Let's move our mempool up. Okay, add resource. Yep. Peer-to-peer host. Peer-to-peer port. Local peer. I don't know why. Why do I need those twice? Can I not do that twice? Okay. Cool. Now remote peers. Yep, got that. Peer flow modifier. Sure, got that. We're just introducing our simulated delay. Syntactic validation, I guess we already had that. I need to remove it. Remove that, and then RPC host, RPC port. Cool, nice. Okay, so that's our Tetra Super demo, and now we need to do all the same stuff to our Tetra demo. Don't know if I can safely. I guess I'll just go through one by one. I'm just gonna fix these imports as well. Oh, whatever, I'll just What do I want to do with that? Copy everything here. Go to local peer. Yep. Yep. And then get rid of that. Get rid of that. Localhost and RPC port. Okay. Hopefully that's all acceptable. Right. So these, yeah, it wasn't happy. Okay. Fix it here first. Fetch transaction is just going to be transaction store dot get or erase. That's the other one. Yay. We need a box state. Hope we have that. We might not have that. We need to create it. It's fine. Also, that's in the wrong spot altogether. Body syntax requires another fetch transaction. I forgot the second one already. Required a transaction syntax validation. And then body body semantic validation. Fetch transaction, we need box state. And then we need a function to create a transaction semantic validation algebra. Okay, so I didn't need that. I needed box state. And then I needed a function. Not that one. Was it? This wanted. Hang on. Sorry. This whole line. So now I need to actually create a box state. What it needs though. Come on. Oh, it needs a lot of things. Of course it does. Current block ID is just Genesis. Come on. Oh, IntelliJ, you're really making me work, aren't you? Thank you. Block body store dot get or erase. A transaction store. Erase. Parent child tree hopefully exists above. And then initial state. Need another store. Guess I can create it here. Okay, hopefully it knows what that is. I don't think that it does, though. Dang it. It'd take 10 years for it to find it. Just import all of cats.data. Okay, so now we got a box state store. I did, and it's like body store. It's because it's block body store. Why didn't it like parent child tree? It's block ID tree. And then it doesn't like slot data store because this is. This is going to be fun. I might have to change a couple more things. Yeah, I don't know. I'll have to figure this out at some point. We have to do a couple things to make that work. But for now, we did quite a bit of refactoring. I realized, I didn't really show the actual validation steps that we run when we handle our blockchain peer. Maybe I can do that in another broadcast next week. But I just wanted to kind of show the integration and the mechanics. There's still a lot more integration that needs to be done, but mostly I just wanted to create this little blockchain module and provide a nicer home, more organized home for some of the stuff that was just filling up our demo program file. So I don't know. I'll pause here for a second, see if anyone's got any questions or whatnot. Feel free to throw them in the chat, and I'll do my best to answer them. And that we'll wrap up here in a few minutes. Alrighty, well, it has been a pleasure. I think I'm gonna wrap it up here. I'll get some of these other things worked out. I doubt I'll continue with this broadcast today, but maybe I will later. With that said, you can tune in, well, I guess about 4.5 hours from now, I'll be doing another broadcast on Quiver, which is essentially our DSL for defining propositions within an extended UTXO system. So I'll be going through some examples. I'll work with James to do maybe a two-party example, and we'll figure it out from there. But so yeah, that'll be in a few hours at 4 p.m. Central Time. So yeah, hope to see y'all then. And in the meantime, feel free to go and check us out on all of our socials. As always, if you have any questions or comments, you can leave them out in the chat, or visit us on Discord. You can see the link there. Other than that, follow us on Twitter, YouTube, LinkedIn, Twitch, and GitHub. And you can also check out our website for more information at topple.co. And we're also hiring. We got a few roles open. You can check us out over at angel.co. A bit more link in the description. And so yeah, this is Sean signing off for now. Hope you all have a good morning, day, night, or evening, and I will see you all in a few hours. Take care.